1 minute ago, volcanic mud began cascading down the slopes of Mayon volcano in the Philippines, not from an eruption, but from something far more insidious. Twin typhoons have just unleashed billions of gallons of water onto volcanic peaks, transforming ancient ash deposits into torrents of liquid concrete. The ground isn't just shaking, it's flowing, and what's happening right now has never been recorded at this scale before. The unprecedented double typhoon trigger of volcanic lahars across multiple peaks. The Philippine Institute of Volcanology issued emergency lahar advisories within hours of landfall, but this was not a single volcano responding to a single storm. For the first time in recorded history, 2 Category 4+ typhoons struck the Philippines within 6 days, dumping catastrophic rainfall simultaneously across multiple volcanic regions. Typhoon Kalmaegi arrived November 3rd, pummeling the Visayas with 148 kilometers per hour winds and gusts reaching 150 kilometers per hour. The storm's eye passed directly over eastern Samar at 6 Coordinated Universal Time, positioning its most intense rainfall bands over dormant volcanic slopes that had not seen significant ash mobilization in decades. Before recovery teams could even assess the damage, Super Typhoon Fung-wong slammed into northern Luzon on November 9th, packing 215 kilometers per hour sustained winds and a pressure drop so severe it registered 943 millibars. The storm's landfall coordinates placed it at 15.8 degrees north, 121.6 degrees east, directly over Dinalungan, Aurora, at 9:10 p.m. Philippine time. But the meteorological data revealed something far more ominous. Fung-wong's massive 1,800-kilometer storm diameter meant its rainfall bands extended simultaneously across Mayon, Kanlaon, and multiple volcanic peaks throughout the northern archipelago. But the true danger was not the wind. It was the water. Meteorological stations recorded rainfall totals exceeding 392 millimeters in Catanduanes alone, more than 15 inches in 24 hours. Similar precipitation rates struck volcanic slopes across 3 major island groups, all of it cascading directly onto ash-covered peaks that had not experienced this level of water saturation since their last major eruptions. PHIVOLCS volcanologists watched their seismic monitoring stations register signatures they had never seen before. Not earthquake tremors, but the continuous vibrations of massive debris flows activating simultaneously across multiple volcanic drainage systems. Volcanic ash that had sat dormant for decades suddenly became weaponized against the communities below. But that is only part of the story, the part we can measure. How typhoon water transforms dormant volcanic material into deadly flowing concrete. Volcanic lahars are not lava, they are something potentially more devastating. When torrential rain hits loose volcanic ash, pumice, and rock debris on steep mountain slopes, it creates a flowing mixture with the consistency of wet concrete, but moving at the speed of a freight train. The physics are terrifyingly simple, yet the scale is unprecedented. Volcanic soil absorbs water differently than regular earth. Ash particles, some microscopic from ancient explosive eruptions, create an almost frictionless slurry when saturated. The volcanic glass fragments that make up much of this material have irregular surfaces that, when wet, reduce internal friction to nearly zero. Add the steep gradient. Of volcanic cones, Mayon rises 2,463 meters, almost directly from sea level over a horizontal distance of just 15 kilometers. And you have built a perfect delivery system for geological destruction. The average slope angle of 30 degrees means gravitational acceleration approaches maximum efficiency for debris flow velocity. Satellite imagery from November 9th captured something unprecedented. Lahar channels activating simultaneously across 3 separate volcanic systems. The Mayon drainage basins, typically dry during November, transformed into brown torrents, visible from space within hours of peak rainfall. Similar flows triggered around Kanlaon volcano, where recent volcanic unrest had already loosened surface ash deposits, making them more susceptible to water mobilization. Philippine atmospheric data reveals Fung-wong's eye wall passed directly over Mayon's summit at peak intensity, meaning the volcano's upper slopes received the most concentrated precipitation at the exact moment when rain intensity reached 50 millimeters per hour. The result was gravitational. Millions of tons of volcanic debris suddenly became mobile, following pre-carved channels toward populated valleys below at velocities reaching 40 kilometers per hour. Unlike volcanic eruptions, which provide hours or days of seismic warning signs, Lahar flows triggered by external rainfall can begin with almost no notice. The warning is the rain itself, and by the time residents hear the characteristic rumble, the flow is already moving downslope, carrying everything in its path: trees, vehicles, buildings, and terrain features that seemed permanent just minutes before. Yet what comes next could be even worse, because history shows these flows do not stop when the rain ends. The 1991 Pinatubo Lahars continued killing for years after the eruption ended. In 1991, Mount Pinatubo erupted explosively, ejecting 5 cubic kilometers of material and covering surrounding provinces with volcanic ash up to 200 centimeters deep. The eruption itself killed fewer than 300 people. But the Lahars that followed killed thousands more over the next decade. Every monsoon season from 1991 to 2001, heavy rains remobilized Pinatubo's ash deposits. The volcanic material had been deposited in a perfect storm of geological vulnerability: steep-sided valleys, loose unconsolidated ash, and drainage patterns that funneled water directly through populated areas. Entire towns, Angeles City, Olongapo, and dozens of rural communities found themselves repeatedly buried under flowing volcanic mud that arrived with each significant rainfall event. The Lahars did not follow predictable paths. They carved new channels, jumped existing riverbanks, and buried infrastructure that engineers had considered safely distant from the original eruption zone. Communities that survived the initial blast found themselves under constant threat from an enemy that struck without warning whenever storms approached. Survivor accounts from that decade described the sound first: a low rumble that residents initially mistook for distant thunder or military aircraft from nearby Clark Air Base. Then came the smell: sulfuric, metallic, like wet concrete mixed with rotting vegetation, and something chemically acrid that burned the nostrils. By the time families could see the brown wall of debris approaching, often 3 to 5 meters high and moving faster than a person could run, evacuation was no longer possible. The Lahars moved with such density, they carried entire houses, vehicles, and 30-meter trees, as if they were floating cork. When the flows finally stopped, they didn't just leave mud, they left a concrete hard surface that required industrial excavation equipment to penetrate. Recovery teams found victims buried under lahar deposits that had hardened to the consistency of sidewalk pavement, preserving tragic evidence of the flow's speed and power. The lesson from Pinatubo was clear: the volcanic threat doesn't end when the eruption stops. Every significant rainfall event becomes a potential trigger for renewed flows, mobilizing the same ash deposits year after year until natural erosion finally stabilizes the slopes. Some lahar channels around Pinatubo remained active for more than a decade after the initial eruption, claiming additional lives with each major storm season. And now, scientists fear history may be repeating itself across multiple volcanoes simultaneously. Multiple volcanic systems now primed for ongoing lahar activity across the Philippines. The current situation represents something far more complex than the single volcano scenario. At Pinatubo, 3 major volcanic systems, Mayon, Kanlaon, and smaller peaks across Luzon and the Visayas. Fresh ash deposits are now saturated and destabilized by unprecedented rainfall totals. The geological threat has multiplied exponentially. Emergency responders have confirmed active lahar flows in at least 4 major drainage basins around Mayon volcano alone, with additional flows reported near Kanlaon and smaller volcanic peaks throughout the affected regions. These flows have already isolated several communities in Albay province, cutting primary road access and forcing emergency helicopter evacuations from areas that were considered geologically stable just 72 hours ago. Unlike the planned evacuations ahead of the typhoons, which relocated 1.4 million people using established protocols, these are reactive rescues from areas where no evacuation plans existed. Emergency teams describe lahar-affected zones as moonscapes, familiar terrain completely transformed by flowing volcanic debris that has hardened into unrecognizable geological features. The cascading infrastructure damage reveals the destructive efficiency of the Lahars. In addition to the 178 confirmed typhoon fatalities, emergency teams report hundreds of additional people missing in areas where Lahar flows intersected with storm surge and floodwaters. Search and rescue operations have been suspended in some valleys because the volcanic mud remains too unstable for ground teams to safely navigate, and the hardened deposits are too dense for standard rescue equipment to penetrate. Official damage assessments show 105 roads and 46 bridges rendered impassable across the affected regions. But those numbers do not capture the longer-term implications. Many of these transportation corridors cross volcanic drainage channels that are now filled with hardened Lahar deposits up to 4 meters deep. Full reconstruction will require comprehensive geological surveys to determine which routes remain vulnerable to future flows, potentially redrawing the infrastructure map of entire provinces. The economic implications compound daily. Agricultural damage has already reached 142.29 million Philippine pesos, with thousands of hectares of rice and cornfields buried under volcanic debris that will require complete soil replacement before farming can resume. Power restoration efforts face similar geological obstacles, as transmission towers in affected areas now sit atop unstable Lahar deposits rather than solid ground. The meteorological forecast compounds these concerns exponentially. The Philippines remains in peak typhoon season through December, with Pacific water temperatures still elevated enough to fuel additional intense storms. Each subsequent rainfall event above 50 millimeters in affected areas carries the potential to remobilize the fresh Lahar deposits, creating a cycle of recurring geological hazards that could persist for months or years. Because what happens next could rewrite evacuation maps across 3 island groups. The volcanic threat timeline remains completely unpredictable and potentially multi-year. PHIVOLCS continues 24-hour monitoring of all affected volcanic areas using seismic stations, thermal sensors, and real-time precipitation gauges. But the data reveals an uncomfortable truth. Lahar prediction remains more art than science. Unlike volcanic eruptions, which produce measurable seismic precursors hours or days in advance, rainfall-triggered debris flows can begin with minimal warning across multiple drainage basins simultaneously. Current volcanic alert levels haven't changed. Mayon remains at alert level. Kanlaon is at alert level 2 because the volcanoes themselves are not showing increased eruptive activity. The magma chambers remain stable, gas emissions show no significant changes, and ground deformation measurements detect no unusual swelling or subsidence. The danger comes from above, not below. Every weather system approaching the Philippines now represents a potential geological trigger for millions of tons of loose volcanic material. International volcanic monitoring specialists describe the situation as unprecedented in scale and complexity. The Volcano Disaster Assistance Program has documented individual Lahar events at dozens of volcanoes worldwide, and single volcano scenarios like Pinatubo have been extensively studied. But never before have multiple volcanic systems responded simultaneously to sequential super typhoon impacts across such a compressed time frame and geographical area. The implications extend far beyond immediate emergency response. Agricultural areas in affected provinces may remain unsuitable for farming for multiple growing seasons, as Lahar deposits alter soil chemistry, drainage patterns, and topography in ways that conventional agricultural recovery methods cannot address. Some areas may require complete soil replacement, a process that could take years and cost billions of pesos. Reconstruction planning must now factor in geological hazard zones that did not exist 2 weeks ago. Settlements that have existed safely for generations now find themselves in active volcanic drainage channels. Urban planning officials face the unprecedented challenge of relocating entire settlements while designing new infrastructure around volcanic hazards that may persist indefinitely. Perhaps most unsettling, the twin typhoon scenario that triggered these flows remains climatologically possible throughout the remainder of the 2025 tropical cyclone season. Pacific water temperatures exceeding 29 degrees Celsius and atmospheric patterns that enabled the rapid intensification of Kalmaegi and Fung-wong show no signs of stabilization. Climate models suggest similar compound storm events may become increasingly common. The Philippines has weathered countless typhoons and volcanic events throughout its recorded history, developing resilient communities and sophisticated disaster response protocols. But the convergence of extreme meteorological events with multiple volcanic systems creates a new category of compound natural hazard, one that may be impossible to fully prepare for until it happens again.